Welcome everyone. In this walkthrough, we'll look at an exam question involving some of the reactions of aluminium compounds. I'll start with a description of key terms associated with this topic. The question is taken from an A-level chemistry paper. Details are in the description. Let's get started. In the photograph on the left, I'm holding a model of a complex ion. A ligand is a species that donates a lone pair of electrons to a central metal cation to form a coordinate bond. Water molecules can act as ligands. A central metal cation surrounded by ligands is called a complex ion. Molecules of water, H2O, are polar. The shape of each molecule can be described as angular. Oxygen is more electronegative than hydrogen, so each oxygen atom has a slightly negative charge. Each hydrogen atom has a slightly positive charge. There are two lone pairs of electrons on each oxygen atom. Water molecules can act as ligands to form complex ions. Aluminium ions form the hexaaqua complex in water. The hexaaqaualuminium free ion has an octahedral shape with a 90-degree bond angle. Many complex ions have this shape. Wedges and dotted lines are used to represent the three-dimensional shape. This is studied in Year 1, Structure and Bonding. The wedges, shown in red here, are used to represent bonds coming out of the plane of the page or screen. The dotted lines, shown in red, are used to represent bonds going into the plane of the page. One lone pair of electrons on each water molecule is donated to form a coordinate bond with the central metal cation. Two dots represent a lone pair, shown in red here. The complex is shown in square brackets with the charge, 3+ in this case, at the top right. A monodentate ligand is a ligand that makes one coordinate bond. The total number of coordinate bonds made to the central metal cation is known as the coordination number. The photograph on the right might help you to visualize what the 3D diagram represents. It is not necessary to show the three-dimensional shape when representing complexes like this in balanced equations. The chemical formula for this complex is given in red here beneath the name. The state symbol AQ shows that this is an aqueous complex ion. Here's the first part of the question. When anhydrous aluminium chloride reacts with water, solution Y is formed that contains a complex aluminium ion Z and chloride ions. Give an equation for this reaction. Aluminium chloride has the formula AlCl3. In the presence of water, the hexaaqua complex ion will form. We are told in the question that chloride ions are also formed. The balance equation is given in blue here. Here's the next part of the question. Give an equation to show how the complex ion Z can act as a Bronsted-Lowry acid with water. A Bronsted-Lowry acid is defined as a proton donor. Complexes of cations that have a 3+ charge often act as Bronsted-Lowry acids. The charge density of the central metal cation is great enough to weaken OH bonds in water ligands. A water ligand within the complex can lose a proton, forming a hydroxide ligand. The charge of the complex ion changes from 3+ to 2+. A hydronium ion, H3O+, also forms. Here's the next part of the question. Describe two observations you would make when an excess of sodium carbonate solution is added to solution Y. Give an equation for the reaction. In your equation, include the formula of each complex aluminium species. We know that solution Y can act as a weak acid. You might also recall that when an acid is added to a carbonate, carbon dioxide and water are produced. The ionic equation shown here might be a starting point to get you to think about solution Y as a weak acid. However, to get the marks, we have to show solution Y as a reactance rather than H+ ions. We have now started to build the full balanced equation. State symbols are linked to observations. The carbon dioxide produced is a gas, so fizzing will be observed. Another product is formed, a precipitate. A large part of complex ion chemistry involves learning the balanced equations and observations. Find out which complex ions are on the specification for your exam. Lots of marks are available for knowing the colours of solutions and precipitates associated with these reactions. In total, 3 water ligands in each aluminium ion donate a proton. The other product is shown here. This is observed as a white precipitate. Square brackets were present around the aluminium complex product in the mark scheme for this paper. I have also seen this product written without square brackets in textbooks. I was personally taught that square brackets are used to represent complex ions in equations like this. I think that square brackets are used by some to represent any complex, regardless of whether it is an ion or neutral. The final mark is for balancing this equation. This part of the question is now complete with the observations and balanced equation given in blue. Here's the final part of the question. Aqueous potassium hydroxide is added until excess to solution Y. Describe 2 observations you would make. For each observation, give an equation for the reaction that occurs. In your equations, include the formula of each complex aluminium species. If the ligands in a complex are replaced with different ligands, this is known as a ligand substitution reaction. Ligand substitution reactions can occur if the other ligand is in a higher concentration or if the other ligand forms stronger coordinate bonds with the central ion. Potassium hydroxide, KOH, is a source of hydroxide ligands. In the first stage, the same product that we saw in the previous part of the question is observed. A white precipitate is formed and the balanced equation is shown. When excess hydroxide ions are added, further substitution occurs and the precipitate dissolves. The second equation given here shows a change in coordination number from 6 to 4. The balanced equations are shown in blue and the question is complete. Some sources state that the final product is AlOH6 3-. This is shown in red. This alternative was also allowed in the mark scheme with the corresponding balanced equation. Thanks for watching. I hope you found the video useful. Please post in the comments if you have any questions or suggestions. Take care and good luck with your studies.